Hello, everybody. Welcome back. Today is December 31st. So, Happy New Year. So, the problem 15 is just similar as problem 14, and we need to determine the final force acting on the point 2Q. They're giving us the length, which is L, and they're also giving us the charges of each point. So, at the very end, we're gonna have the point and three different forces coming from the other charges. So there's gonna be a force coming from the charge 3Q vertically and another force coming from the charge Q horizontally. What we're gonna do? We're gonna take these two forces and we're gonna make a new force using these two components. So this is gonna be one of the final forces. In addition, we're gonna have another force coming from 4Q. So at the end, we're gonna have this force plus this force acting along the diagonal. You see it? Along the diagonal. So remember, we're gonna be using Coulomb's law, which is F equals Coulomb's constant times the product between the two charges over the distance squared. So let's find the magnitude of the forces. Let's start by this force, which is the Q acting over 2Q, right? So we have Coulomb's constant times. So the first charge has a value of Q. The second charge has a value of 2Q. All right. Over the distance, which is L squared. That's going to be equals to 2K Q squared over L squared. That's good. This is going to be acting on the X axis. What about the charge 3Q? Well, it's kind of the same. 3Q acting over 2Q is going to be equals to Coulomb's constant and the product between charges. So the first one is 3Q. The second one is going to be 2Q over the distance square. That's going to be equals to 6Q Q squared over L squared. Now, we have this force and this force. Let's combine them. Let's put them together. So we're going to have a force just like this. So how we're going to do that? So we have a horizontal force and a vertical force. Well, that's going to be a straight triangle. So the final component is going to be equals to, so let's call it combined force. So combined force is going to be equals to square of 2K Q squared over L squared square plus 6K Q square over L square. So what am I doing? This is just like a straight triangle. We're gonna calculate the hypotenuse. And in this case is the resulted force, magnitude. And we're applying Pythagoras, which is hypotenuse equals to square of size A square plus size B square. So let's find their magnitude. So combined force is equals to, so that's equals to 6.32 K Q squared over L. Beautiful. So now we have this magnitude pointing along the diagonal. What we need to do next? We need to calculate this force that corresponds to the charge 4Q. All right. So the force of 4Q acting over 2Q is going to be equals to Coulomb's constant, the product between the two charges. So the first one is 4Q, the second one is 2Q, over the distance. What is the distance? If you have a straight triangle and the sizes and the two sizes are alike, the hypotenuse is going to be square of 2L. So this is going to be the distance. That's equals to what? And that's equals to, now this magnitude corresponds to this vector. And this magnitude corresponds to this vector. What are we going to do? The net force is equals to 4K Q squared over L squared plus 6.32 K Q squared over L squared. And that's equals to 10.32 coulombs constant Q squared over L squared. Well, we know that coulombs constant is 8.910 times 10 to the 9, right? So the net force is equals to 91.8 times 10 to the 9 Q squared over L squared newtons. And the direction is a vector coming from the center along the diagonal. In another word, it's going to be 45 degrees. So I hope you find this exercise helpful, and I wish you all the best to you guys. Happy New Year. Bye bye.